Good morning, everyone. We're team 12 and we'll be presenting the propulsion system for the Department of Transportation Trolley. My name is Martinez.
My name is Rodolfo Guerrero.
My name is Bustamante.
So the Florida Department of Transportation is researching ways to lower the emissions of carbon dioxide to the atmosphere. They're doing this by implementing hybrid electric vehicles into the fleet. Currently, 2 previous senior design teams have worked on this problem. As you saw in the previous demonstration, the solar thermal collector, which is currently going to be placed at the top of the trolley, as well as an AC unit. The AC unit is currently being installed at the back of the trolley, and once this process has been completed, we will have the trolley here at school. So the goal of this design is to have a propulsion system that incorporates all the other senior design projects all together as one system to have a hybrid electric trolley that will be able to operate from engineering campus to main campus. Here is an example of an electric propulsion system that consists of a battery that powers the motor / generator that then powers the transmission that propels the system forward. We hope to integrate such an electric propulsion system with the current fossil fuel systems and hope to have a hybrid system that powers the whole trolley.
So for our project, we did extensive research on all the components that we need for the system itself. First thing we did was look into electric motors. Here we're mainly going for a DC motor, and we researched that and we found that there's 2 types, the brushed and brushless. We're mainly leaning into a brushless DC motor because since it doesn't have the brushes, it doesn't have any friction of the brushes as it rotates, which reduces the torque loss if it were to be brushed. And if we don't go into a DC motor, we also look into an AC, but we did see that if we go into an AC, we would need a converter in order to implement it into our system. So that's why we're going mainly with a DC. One of the other components is the battery packs for the fuel cells. Right now we looked into that and we found out that there's 2 types, a nickel-metal hydride and the lithium-ion battery pack. Also, our system will, the ideal purpose was to have a generator and an ICE, the internal combustion engine, to work in conjunction with the system itself. But we also look into generators that will serve as ICE because both of them will run with natural gas or propane, depending on which one we pick to go with. For the fuel, as I mentioned, it's the natural gas or the propane. The ideal purpose is to use natural gas, which we found out that there is compressed natural gas and liquefied natural gas. But we're also looking into propane just in case an alternative fuel source. Here we have our survey-related standards. These are the most relevant ones to our project, which, as you can see, they are mostly the Society of Automatic Engineers. The standards talk about electric vehicle safeties as well as fuel safeties and the performance of motor safeties. But just so you know, this doesn't limit us to other standards. We'll also look into ASME for manufacturing purposes and IEEE for working with any of the electrical systems. And we're also looking into the FDOT standard because this project is for the FDOT. Over here, we have some of the design specifications and calculations. The main goal for our system is for it to propel our trolley at a top speed of 40 miles per hour. This is with the propulsion system carrying the whole system as a whole, which is estimated to weigh from 5 to 5.5 tons. That is taking into consideration all the components being put together, as well as all the people that the vehicle will transport. Now, as you know, the trolley will be traveling from EC to the main campus or main campus to EC. You know that there is a hill on 109th and 8th Street, that intersection. So because of that, we took into consideration a 14-degree angle. So because of that, we want our trolley to be able to go over that hill and maintain the 40 miles per hour, as well as if for some reason it was stopped at that red light, it will be able to start from 0 and go over the hill. Now, with that being said, our estimation right now for the horsepower of the motor will be 250 horsepower. This is due to all the requirements so it can fulfill it.
Good morning. So I'm going to introduce our initial alternative designs. Once presented with the project and after our initial research, we came up with 3 possible powertrain configurations. We ultimately decided on a series hybrid due to simplicity, availability of manufacturing, our personal knowledge. We originally wanted to go with a plug-in hybrid. It's the most widely used hybrid form of vehicle right now. It's what Tesla uses, Nissan. They mostly all use it. The reason we didn't go with a plug-in hybrid, it's very expensive to prototype, and it becomes more of an electrical engineering issue. It's just something beyond our reach. And we also decided against the parallel hybrid, which, as opposed to the series hybrid, uses both the internal combustion engine and the electric motor in unison to power the vehicle. Again, it was just something too complicated. We didn't think we'd be able to complete it in time. So we decided with the series hybrid, which is just from our ICE, powering the generator, powering the electric motor, powering the trolley. Within our decision to use a series hybrid, we have a few other alternatives. We're debating whether or not we'd like to include a Stirling engine as a regenerative form of, as a regenerative power source, right? And the Stirling engine works in unison between a heat sink and a heat source, creates a pressure differential, which moves our piston. We're not sure whether or not we can implement it. We haven't received the trolley yet. So a lot of our design alternatives depend entirely on spacing, how much space we have on the trolley, how much space we have to work with in implementing things. We're debating what type of fuel source to use. He presented both options right now, the LNG, liquefied natural gas, or compressed natural gas. They both have pros and cons. Unfortunately, we can't decide until we have the trolley. All right, the difference between liquefied natural gas or compressed natural gas versus gasoline is the space requirement for the fueling tank. All right, liquefied natural gas takes about 4 times as much volume versus gasoline for the same amount of, for the same range, for the same power generation, and compressed natural gas takes about 10 times, even though it's about 10 times cheaper as well. So that's the trade-off. Until we get the trolley, we can't decide for sure. We were also debating whether to use a lithium-ion fuel cell or a nickel-metal hydride. We ended up ultimately deciding on nickel-metal hydride because of its cost and availability. Lithium-ion fuel cells are not sold commercially, and we would have to go out and find a decommissioned vehicle with a fuel cell, take it off, and then repurpose it. Again, something just too complicated for our purposes. And lastly, we're debating whether or not we're going to use the solar collector as a way to power, to help charge the battery or power the electric motor, or if we like to use it to power auxiliary systems. All right. Our project encompasses a global design because we're trying to make something that's we're trying to make a trolley that's lower emissions. I'm sorry, trying to make a low emission vehicle. All right. It's we hope that this helps prevent the onset of global warming. It also cuts down on the use of fossil fuels around the globe. It also cuts down on the lifetime cost of transportation, which we hope can bring these type of green, non-emission transportation systems to impoverished countries. To conclude, our project encompasses design of the series hybrid propulsion system for the Department of Transportation. We hope to make a cleaner emission vehicle as opposed to the fossil fuel vehicles being used right now. And for future works, we hope that this project can lead into a fully electric trolley with no emissions at all.
As you can see here, this is our Gantt chart. It's going a timeline that consists of the spring 2017 term and the fall 2017 term. It is just a timeline that has all our goals. That way we can finish our project in a timely manner. As of right now, we're dealing with the design and analysis, which is right there in April. And now I would like to open up the floor for any questions.
First thing I throw out is contingency. You may never get that trolley until the last minute. So are there ways that you can get there, get some measurements, scale the area that you need information on, so that you can get started?
That's the last day.
Don't assume that.
Huh?
Don't assume that.
if it's not here on the 26th, are you going to be heading over there to be able to take a measure?
Absolutely.
Yes.
Because you should be able to design this without the trolley in your hands. And you need to. That's just the first guidance question. The other question I have is, and I like the part where you started to simplify, where you set up a hybrid that actually used the into series versus the parallel, because that was going to be a very complicated problem. Even the serial solution is a complicated problem. And so you just got to make sure that you've got your timing right and your thought process right, so that if some of that doesn't work, you still have a project at the end. So I want to make sure that you take that into account. Okay. Guidance.
Please.
Just as a follow-up, can you go back to your Gantt chart?
Yeah.
So, some of these things, like assembly, saying May and June for a huge, I don't know that Ford Motor Company could put together this trolley in 2 months with their infrastructure, right? So again, how did you guys come up with some of these estimated times? Like, it seems like most things just for 2 months, right?
Well, yeah. I mean, we just kind of made like a generic timeline just to help us keep time on our goal. But if it does come to anything, we might have to change some of these goals at times.
So the idea would be try to be over, some of these times, right? These all seem very, 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 very optimistic in my opinion. I mean, you guys said proposed design is done in March. To be honest with you, I didn't see a proposed design, and that should have already been done, right? I know you guys are waiting for measurements and things like that, but do you have any specific parts that you're ready to order? Or is it you're completely waiting for this trolley to show up?
So our biggest issue is that, like I said, we don't know exactly where we would be able to fit everything. We haven't been able to physically see the trolley.
So then move this whole thing, so take March and go till the 26th, right? So anything that's in March here now starts on the 26th, okay, of April, I'm assuming. I hope April, right? So you're already 2 months behind on everything that's up there, correct?
Correct.
Okay.
The thing is, we were originally supposed to get the trolley last month.
So what if the 20, again, the same sort of thing. You can't wait for this thing to come to start. You can't.
Sorry.
So a comment about the Gantt, again, building up on it, the trolley could fall off of the truck bed and now you don't have a trolley. I'm sure the city or the manufacturing company might have some dimensions that you can get in touch with them. They probably made thousands of these carts, or as you say, just go to a similar trolley and get the measurements. On your Gantt, you should mostly try to plan right to left instead of left to right. So you're trying to see what is the latest I have to start this task before I start going into a critical path. Critical path is when you already know that if you don't hit that date, you're late. So by your comments, you're way past critical path here. So if all these measurements or all these dates are true, this project won't be completed in 2017. So just something to consider when you do go back and redo your Gantt chart. Look at worst case scenario, this is when I need to start this task in order to finish by that date. Natural gas, you mentioned it. I've seen this system before in third world countries. A lot of taxis have fuel or fossil fuel cars that get converted for a couple $1,000s into fully compressed natural gas. So I would do some research into that. I know you mentioned it's 10 times more, it takes 10 times more space. However, I've seen these systems fit in part of a truck, of a car. So just look into, maybe there's a solution there that you could implement and just drive with that.
Something else as far as using electrical and natural gas, maybe you want to consider what current cars are doing, where you use the electrical part of it for when your vehicle is stationary. Power AC, power your radio, all the electrical controls, and just do the gas, the natural gas as your sole source of power. That way you don't have to figure out a way of integrating both a motor and an electrical motor, and how you're going to split the power, how you're going to combine those into the same drive system. You can just keep them completely separate.
Well, you guys can, I'm sorry.
Oh, no, it's a quick, I know we're running out, but a quick comment, no need to answer. It's just you were talking about the 14-degree angle on the ramp. I would also be interested in seeing what the maximum angle will be. So I would calculate that to ensure if you get to the slope, you can move anywhere, you know, just add that.
Oh, include full weight too.
Okay.
If your whole trolley is full, occupied, or even do a little bit more, you know, if it's 110% capacity, can you still do that ramp? Or if you're just going to be able to go above that ramp with a completely empty trolley.
Where you guys have the prototype improvement of 4 months, maybe we can cut it down to 1 or 2 months, and then we can move everything else, taking into account the comments of the assembly cost and the stuff. Maybe the improvement doesn't need obviously 4 months, it could be less.
You need
If
to
you're
be done with
perfect
all
from the
your
beginning,
testing in
right? If you're
November,
perfect from day one, but
so that you don't have trouble getting the report done. So that should be your target, finish testing and analysis by November, end of November.
Okay. My question is a similar question that I had about previous group. And it has to go again with the motivation and your problem statement. In your motivation, you talk about reducing the carbon dioxide emission to the atmosphere, and again, you mentioned that again in your problem statement. So, how much are you trying to reduce? Quantitatively, you need to say something. I mean, going from what percent to what percent? Are we going to reduce it by 2%, 3%, 10%, 100%? I mean, what's your goal?
The only reason we didn't put in what the actual savings in emissions would be is because they vary very differently between liquefied and compressed natural gas. For compressed natural gas, it's about a 30% decrease in emissions. For liquefied, it's about 50%. Again, depending on what we can implement, we would go from there. So that's why we didn't put in like exact numbers until we decided.
But you need to have some sort of number in your final project. You can't just say reduce.
Of course.
You have to say reduce by 2%, 3%, whatever.
One last thing to include in your report, distance, right? You're mentioning speed, but you know, how far can this thing go before it needs to be refueled? Or what's your operating range? That's really what I'm looking for.
Right.